transformation of a function is you take one function and you get another function. That's called the transform. So there's the Laplace transform, and there are various other transforms. There's the Fourier transform, which is related to the Fourier series that we learned. And I can't remember other ones, but there are many. Okay. So what's the Laplace transform? Laplace transform of a function f of t is defined as follows. You integrate from 0 to infinity of e to the negative st of f of t dt. Now, even before trying to understand what this does, I think the best way to understand it is to see what this. You can just calculate the right side, and that could give you a better understanding of what this integral is doing. Okay? So let's do the simplest one I can think of, which is Laplace transform of a function t. That's simple enough, right? So let's try this.
See ya.
Okay, this is a letter S, not 5. But even if you treat this as 5 and later change that number to S, 5 into S, it's not going to be wrong for simple cases like this. So if it helps in coping with this unknown letter S, just think of it as a number like 5 because it's similar to 5. So let's try to integrate it. I guess we will need the tabular integration, so let's use tabular. T is what you want to differentiate because it's going to go away. T becomes 1 if you differentiate. If you differentiate again, you get 0. And then e to the negative st, if you integrate this, what do you get?
1 over negative s.
1 over s, negative 1 over s, e to the negative st. And every time you integrate, this negative 1 over s pops up, so the next integral will be 1 over s squared, e to the negative st. And you have plus, minus, plus. Now let's figure out what the tabular integration brings us to. It gives you negative t over s e to the negative st. And this one will give you negative 1 over s squared e to the negative st. And then the last row has to be multiplied together and you have to integrate. That just gives you constant c in this case. Alright, so anyways, the integral we obtained is the following. We get negative t over s e to the negative st minus 1 over s squared e to the negative st. And you have to plug in infinity and 0. Now here the assumption is s is some number big enough. So s has to be some big number, big positive real number, so that these integrals converge. So let me ask, what do you get if you plug in infinity here? So s is some positive number, so infinity times some positive, that's infinity. So this one will become e to the negative infinity. What's that? That's 0, right? E to the negative infinity is 1 over e to the infinity, so it's 0. Okay. Now, if you plug in infinity here, that goes to infinity, right? But this is a polynomial, and this is like a exponential function in the denominator, right? So which one wins? If a polynomial goes against the exponential growth, exponential wins, right? So if you plug in infinity, this will become what? 0. Because this goes to 0 much quicker, than how t goes to infinity. So this becomes 0. Same thing here. If you plug in infinity, it's going to get 0. So in fact, what happens is that this infinity is there so that when you plug in infinity to these exponential decreasing terms, you get 0. That's the purpose of having infinity at this point. Okay? So those gives you 0. So if you plug in here, nothing survives. Now what do you get if you plug in 0 here in the first one? Remember, we are integrating by t, so these are actually values of t. T equals to infinity, t equals to 0. So you're plugging a 0 into t. What do you get if you plug in t equal to 0? Yeah.
0.
Why?
Because t times.
Because t is
Yeah.
here, and that's 0. 0 times anything is 0. So that's 0. How about this one?
Negative 1 over s squared.
To the 0th power, e to the 0th power is 1, so you just get this, right? But because you have to do this plugged in minus this plugged in, what you're getting is 0 minus negative 1 over s squared, which gives you 1 over s squared. Okay. So this is the Laplace transform of the function t. So the result that we just found out is that Laplace transform of t is 1 over s squared. All right, now let's try to understand a little bit more about this Laplace transform. So what is it doing? You take a function of t and it gives you back a function of s. You give it, so it's some kind of a pet that you have, you feed it and it gives you back something, I don't know. Not a good analogy. But you feed it a function of t, it gives you back a function of s. That's basically what it does. Why would we want to do this? Well, it has the following properties. First, because it's an integration operator, because it's just integrating against some. This is called a kernel of a transform. So this type of transformation is called an integration operator. Integration operators are good because if you have a constant multiple, you can pull that number out. So for example, if I wanted to know what Laplace transform of 3t is, what would that be? This 3, because if it's here, then you can pull it outside the integral. You can pull it outside. And it gives you 3 over s squared.
No, it's not a screw, it's a pin.
And then
That's what I
another
hate
thing
about it.
is,
You gotta screw the whole lens to the pin, which you put the pepper piece on, and the other side goes on.
if you compute this one, you're going to get 1 over s. So let's just accept that. You can. This is even easier than this one. You don't even need integrate by parts. You just integrate and plug in the endpoints. You're going to see that it's going to give you 1 over s. So just accept it as true. And in that case, if I have, knowing this and this, knowing this and this, if somebody asks you what is Laplace transform of 5t plus 7, what would this be? You just take individual terms and do Laplace transforms of it. So you get Laplace transform of t, which is 1 over s squared, and Laplace transform of 7 is 1 over s. So that's the Laplace transform that you get. Okay? You can put 5 over here if you want. That's how you solve Laplace transforms. Okay? So it enjoys this property. Another important property of the Laplace transform is the following. If you have Laplace transform of a derivative of a function, this is 0 to infinity of e to the negative st f of x, f prime of x dx. Okay, this one I want to do integration by parts, not tabular. So sorry if you don't know integral by parts, you only know how to do tabular. You can do it with tabular, but this is easier with integration by parts. So I'm just going to say du, udv is d, okay. So dv is equal to f prime of x dx. And then u is equal to e to the negative st. And that means v is, what's the antiderivative of this? F of x itself, right? And then if you differentiate that, du is, yes?
Should f of x be f of t?
Oh,
I'm-
thank you,
I'm
thank
sorry.
you. That's a good catch. Thank you, thank you. All right. Then du is, if you differentiate by t, you get negative s e to the negative st dt. Okay. And then if you use the formula that integration of u dv is uv minus integration of v du, applied to this, you get the following. It's what's uv? This time this. So e to the negative st f of t, infinity and 0 should still be applied, and then minus v is ft, and du is, let's see, let's write it like this, ft negative s e to the negative st dt. And then if you plug in infinity, e to the negative infinity gives you, every time you plug in infinity, you're going to get 0. Just accept it. Of course, actually, I'm kind of lying. For this to happen, f of t can't grow too quickly, meaning that if it grows faster than this function, then it doesn't go to 0, right? So there are certain conditions that f of t must satisfy. It can't be growing faster than a certain exponential function. But I'm not being very rigorous at this point. I'll just say this is not going so fast, so it goes to 0. And then when you plug in 0, what do you get? E to the 0 is? And f of 0 is? F of 0. You can't control it. So and because when you plug in this, you have to subtract this minus f of 0. And then minus minus becomes positive, and because s is considered as a constant, see s is not dt, s is not t, so it's a constant, you can pull it outside. So I can pull it outside and write it as s times 0 to infinity f of t e to the negative st dt. But if you switch you can switch these two around, right? So what is this? That's the Laplace transform of right. So that's the important formula. These are the basic problems.